Let's consider a vendor who buys 2 newspapers every day, and the price of each newspaper is W euros. That is how much the vendor pays for a newspaper. And the selling price that the vendor sells to customers is R euros. Obviously, R should be greater than W in order to make some profit. In the end of the day, some newspapers may be unsold, so the vendor can return the newspapers to the supplier and recover a portion of the cost, which is S euros. The demand is uncertain. Every day it's not known how many newspapers will be sold. In order to deal with this problem that involves uncertainty, we need to estimate the probability distribution or probability density function of the demand. So the question is, once we have this probability density function, what is the optimum number of newspapers that the vendor should buy? And when we talk about optimum, we mean that we want to optimize the expected profit or average profit. Some information, the price that the vendor pays is 4.5 euros and sells them for 12 euros. These are expensive newspapers. And the salvage price is 2. The probability distribution of the daily demand, as we said, is normal, and it has a mean value of 150 newspapers and a standard deviation of 40. So on average, the vendor sells 150 papers, but there is significant variability and the standard deviation is 40. Here is the probability density function of the demand, the daily demand. So it is a curve that is symmetric. That's the Gaussian distribution density, which is symmetric. And we see that the center is close to 150, somewhere here, and we have a standard deviation. Now, the expectation of the profit should be calculated, the expected value of the profit. We have first to calculate the underage cost, which is the loss of profit if we buy fewer newspapers than the demand. So the loss of profit per newspaper is the revenue, the price that the newspaper would be sold minus the cost that the newspaper vendor would have to pay. So for every newspaper that was not bought, the loss of profit is 7.5 euros. This is called underage cost. This is occurring when the vendor orders less papers than the demand. The overage cost, which is occurs at the other extreme, when we overorder. That means we order more newspapers than the demand, it is the price that we pay minus the salvage price. Okay, the difference of the two is $2.50. So for every newspaper that was too much to buy, the loss of we lose $2.50. Okay, now we can calculate. The solution requires the calculation of the critical fractile, which is the average cost over the average cost plus the underage cost, and this is 0.75, 3/4. Now the optimum size, as we saw earlier in the previous lecture, is the smallest integer, such that the probability that we cannot meet the demand is equal or exceeds the critical fractile by that probability. So we should order that much so that the probability of being unable to meet the demand is equal to this critical fractile. So using this piece of information, we can find the optimum, that fractile, which is the optimum number of newspapers that we should buy to maximize the average profit. And using doing this calculation, we find that a number that is 176.98. Now, the vendor cannot buy 176 and 98ths of a newspaper, so we need to just find the integer, the closest, the integer, an integer number. Now, in this case, it is obvious that the optimum number of newspapers is 177, because 176.98 is awfully close to 177. But in other situations, it's not that simple just to round to the nearest number. So what we do is compare the, if we compare what will happen if we buy 178 newspapers, or 177, or 176. Okay, so this is the equation for the expected profit, and we calculate the expected profit for the three cases where we buy one newspaper more than the 177, and expected profit that if we buy one newspaper less. And we should, if the calculations that we did are correct, then the optimum number and the profit should be maximum at 477 newspapers. So calculating the expected profit for 176 newspapers using this equation, the above equation, which is giving the expected profit as a function of the newspapers ordered, we find that if we buy one newspaper below the optimum value, that is 176, the expected profit will be 997 euros and 79.6. If we buy 177, the number increases, the average profit increases to 99.7 and 0.834, a little bit higher. And if we over-order, so we order 178 newspapers, the profit decreases. And now it becomes 9.997.792, which is a little bit lower than the profit for 177. So this confirms that what we found, the optimum number, is correct. Here is a plot of the expected profit as a function of the number of newspapers. So we see that if we order too few newspapers, say something like 50, the profit is quite low. As we keep ordering more and more, the profit increases and reaches the optimum value somewhere, as we said, around 270 something. And then if we keep ordering more, then we just have to scrap newspapers, so the profit stops dropping. So this is the optimum value. So in conclusion, this calculation shows that one should order 177 newspapers.